This video is about two-factor ANOVA with Kij equal to 1. The two-factor ANOVA is the analysis of variance with two factors, meaning that there is a factor A with I levels and a factor B with J levels. Each product of a factor A and a factor B is treated as an individual observation, or IJ treatment, hence why Kij is equal to 1. Within the two-factor ANOVA, we have the fixed effects model. This model is where the true average result is due to factor A at the I level and the factor B at the J level. To be clear, that means that factor A is completely independent from level J, which corresponds in this case to factor B. These two graphs do well in showing how an additive model would behave. It's more linear and pattern oriented, whereas the non-additive model is all over the place and more random. And whereas single factor ANOVA had two sums of squares, now we have four sums of squares in the two-factor ANOVA. We have sum of squares, errors of all treatments, sum of squares between, and sum of squares due to error. But the fundamental identity is that the sum of squared errors of all treatments is equal to SSA plus SSB plus SSE. These two hypothesis test statistic values are used to confirm that there is no effect on the true average response from factor A onto factor B, and no effect on true average response from factor B onto factor A. Two-factor ANOVA can be used by engineers in many different fields. I specifically thought of environmental engineering, in where, let's say, there's certain types of pollutions in an area, and maybe different methods will have different amount of efficiency in making cleaner water, cleaner soil, improving crop growth efficiency, things like that. You could test this out in a much simpler way by just trying out different fertilizers for, say, coffee, and testing them out individually and seeing which ones grow better in which conditions. All in all, the importance of two-factor ANOVA is finding out whether or not the factors you're using in your calculations do have a significant effect.